energy. You've heard the word before. You've used the word before. Energy, oh, I'm low on energy today. I'm real tired. But what really does energy mean? That's what we're going to talk about in this unit, is what is energy, what are some types of energy, how is energy calculated, and how is energy changed from one type or one place to another. So just like before, we're going to write this stuff in red, and you can stop the video at any time if you need to go slower, and you can replay it at any time. So what is energy? Like science definition of energy. Energy is the ability to do work or cause a change in matter. Energy is measured in joules just like work. So when we put the two together, we get the work energy theorem, which says that the work that is done is equal to a change in energy. So work that is applied to an object, a force applied over a distance, causes some kind of change in energy. And that's where we get that formula below. Work is equal to a change in kinetic or potential energy. And we'll get to what those mean in just a second. Energy is needed in order for work to be done. And on the other hand, doing work on an object will change the object's energy. So both are true. We need energy to do work. And then if work is done, then it usually changes the energy of an object. There's many different types of energy. There's PE and KE, and I know you've had IPC, physical science, 4th grade. You've looked at energy before. The P and the K, potential energy, is energy that has the potential to do something. It's stored energy, either because of where the object is, or the arrangement of the object, the type of object that it is, the stretching of the object. Something about the object is storing energy that has potential to do something. The KE, kinetic energy. Kinetic means motion. Kinetic energy is the energy of motion, just like when we were talking about the mobiles. That's one of the options you can work on for your 4th, 6 weeks projects. We talked about kinetic sculptures, sculptures that move. Mobiles are kinetic sculptures. Kinetic is motion. So kinetic energy is the energy of motion. There's many different types of KE and PE. There's gravitational potential energy, and that's stored in an object because of its height, because of where it is above the earth. The gravity has the potential to pull it down and put it in motion, move it down, apply the force of gravity over a distance that it's falling. So gravitational potential is the potential of an object to fall, basically. And the formula for gravitational potential energy is the mass of the object times the gravitational constant, 9.8, times the height of the object. So mass and gravity and height. So with this, we want to pause for a second and practice using our gravitational potential energy formula. So here's a problem here. Work it out. Tomorrow in class, we're going to go over it together and see if you got it correct. Okay, now elastic potential energy. Elastic potential energy, think about an elastic rubber band or the elastic waist in your pants. When you deform an object, squish it, pull it, bend it, then the object wants to go back to its original shape. And that property gives it potential energy, elastic potential energy. And we can calculate elastic potential energy by using K, the elastic constant. That's a property of the material itself. Some things stretch and bend more easily than other things do. And X, which is the distance that is stretched or compressed. The more you bend it, the more you stretch it, the more you push it, pull it, the more energy it's going to store. Then there's chemical energy. Chemical potential energy is stored in the bonds of chemicals. Because these chemicals, like say water, hydrogen, and oxygen, because of the bond, the link between those atoms, breaking them apart, which is work, requires energy. And when you do work to break those bonds, then energy is released, and that's chemical potential energy. Some examples that you use every day are gas that goes in your car. When you burn gasoline, the bonds are broken in that molecule, and that provides energy for your vehicle to move. And food, when your stomach burns the food not burns, but when it digests the food in your stomach, then it releases the chemical energy that's in the bonds of the food that you're eating. Nuclear energy, very similar to chemical, except it's within the atom itself, in between the protons and neutrons and electrons. And nuclear energy is released in the sun, in nuclear reactors, nuclear bombs, radiation therapy like cancer treatment. And you can do it two ways. You can either do fusion, combining two atoms together and releasing energy, or fission, splitting an atom into two smaller atoms, which releases energy. Kinetic energy. Kinetic energy is the energy of motion. And we can calculate the energy of motion using 1/2 the mass of the object times the velocity of that object squared. So mass and velocity squared. Now you notice the velocity is squared. That means every time you increase your velocity, you have a big, big change in kinetic energy. Now mass and velocity, we've heard this before. What is very simply mass times velocity? Do you remember? Mass times velocity is momentum. So momentum is related, but not the same thing as kinetic energy. So try this one. Underneath my picture here is supposed to be meters per second. We've got a 1,600 kilogram car traveling at a speed of 12.5 meters per second. How much kinetic energy does it have? Use the formula you just wrote down. Try it. Tomorrow in class we'll go over it and see if you're correct. Alright, another type of energy is thermal energy. Thermal energy comes from the movement of molecules in a substance. When you either add energy to a substance by heating it up, or take energy out of a substance, the molecules inside either get more excited and vibrate more, or they get less excited and vibrate slower. And that is thermal energy. It's an energy of heat. It's how fast those molecules inside an object are moving. And we'll talk more about thermal energy in the next unit that we're doing, but we just wanted to introduce it as a type of energy. Thermal energy is related to, but not the same thing as temperature. Temperature is the measure of the amount of thermal energy. Temperature is not energy itself. It's just a measure of how much energy we have. And electrical energy. Electrical energy is the movement of electrons, free electrons, through a conductor. And often we think about electrons that are flowing through a battery or through a wire. And we'll talk more about electricity and electrical energy in a whole unit. We'll get into much greater depth on this. But we just wanted to introduce it as a type of energy. It's the movement of electrons from one place to another. So try this, and again tomorrow we'll come back together and see if you are right. But I have 6 different types of energy. And how would you classify these? Would they be potential energy or kinetic energy? Think about whether something in this is moving or if it's just stored. Okay, stored energy is potential, moving energy is kinetic. So gravitational, thermal, elastic, chemical, nuclear, and electrical. How would you classify these, as moving energy or as potential stored energy? So make your best guess. It's okay if you're wrong. We'll talk about it tomorrow. Okay, so mechanical energy. Mechanical energy is all of the energy that an object has that's due underneath my picture there, due either to position or to the motion of an object. So I have mechanical energy, you have mechanical energy, a baseball flying through the air has mechanical energy, and that's separate from the thermal energy that I may have. The temperature that I am gives a measure of the thermal energy. That's separate from my mechanical. We're talking about kinetic and potential energy. Maybe I'm standing on a ladder. I have potential energy because I'm above the Earth's surface. And maybe I don't have kinetic energy yet, but if I were to jump down off of the ladder, then in the process of falling, I would have less and less potential and more kinetic as I pick up speed on the way down. So mechanical can be transferred between types, between kinetic and potential. But the entire mechanical energy in a system should remain constant. So how much mechanical energy does a 9 kilogram rock, sorry for it being underneath my video there, how much mechanical energy does a 9 kilogram rock have as it falls at a rate of 5 meters per second from a height of 7 meters? So try that out. You remember it's both kinetic and potential energy added together. How much total mechanical energy does this rock have? And we'll get together tomorrow and see if you are correct. All right, law of conservation of energy. Energy is not created or destroyed. I'm sure you've heard that since you were little. Energy is not created or destroyed, but it can change forms. So for total mechanical energy, we talked about that it was kinetic and potential. The total mechanical energy stays the same, but it can change types. Maybe prior to moving, you had all potential and no kinetic, like my example of standing on a ladder. As I'm falling, I gain kinetic energy and lose potential as I lose that height. So we've transferred from one type of energy to the other, but the entire total kinetic energy is going to stay the same. The total mechanical energy, is going to stay the same. So let's try this one. A half-kilogram baseball falls from the top of its arc at 5.5 meters high. So we have a height, we have a mass, and hopefully you know gravity. How fast is it going right before it lands in the outfield? So if it's falling from a height of 5.5 meters, before it hits the ground, how fast is it going? What would its velocity be? So think about this one for a second. Try it, see what you get. And tomorrow, like I said, we'll work them out and see if you were correct. Now, an important thing to remember is that this is only applicable if the system is closed, if we're in that perfect world physics scenario. In the real world, you're going to have a loss of energy coming in, going out of this system. Now, that doesn't mean it's created or destroyed. Remember, it can't do that. It's going to have to go somewhere. So if, like, say, the baseball falling in the outfield, if it does tend to lose some energy, and if we were to measure the velocity right before it hits the ground and find out it's going a little bit slower than we expected it to, where did the energy go? Well, when we talked about forces and we talked about motion, where did the rest of our force or our motion go? We lost some of it to heat energy, which comes from friction. So friction, air resistance, takes some of that energy out of our system. It's not destroyed, it's just taken out due to converting to heat energy. It has to go somewhere, different kind of energy. It also has to come from somewhere. Machines are not perfect. They're not going to be used indefinitely because you have to plug them in. You have to give them a push. Electricity, electrical energy, gravity, pulling something down or letting it fall, chemical energy. Maybe you ate food, which allows you to push a machine. You put gasoline in your car, which allows it to go. It's got to come from somewhere, just like it's going to go somewhere. So this one, I'm going to put the video on the next tab. I didn't want to show it in the video, but do watch this guy in the next tab over. This video is really nice. So hopefully you've made it through your notes. We'll do some discussion tomorrow. We'll work out those questions and see if you were correct. If you have any questions, if you missed anything, if I wasn't clear on something, please let me know, and we will see you next time.